Hello everyone, it's Kaziruddin and my group members Abdul Mohimin and Shazil Rahman. Today we are presenting our work on dynamic analysis of football passing patterns, which is our discrete project. This project leverages concept from temporal subgraph isomorphism to analyze football strategies inspired by the works of Oberoi and Bourgeois. So this slide shows the data preparation, understanding the data set. The data set consists of 12,124 records of football passes. Each record includes player IDs, pass start and end times, and 2D coordinates on the field. However, the data posed a challenge because all records were shuffled and there was no explicit information to separate matches. Our first step was to address this issue by segregating passes into to their respective matches. So this slide shows the how we match segregation strategy. To segregate matches, we used a time-based approach by dividing the data set using pandas.qcut, which will be shown in the code later on. We split passes into 14 unique matches based on time intervals. Each match was further divided into snapshots representing smaller time windows within the match. Additionally, we separated passes into home and away player groups, ensuring the data was structured for further analysis. Now, further on, Moemin will take on.
Now coming towards the adapting the techniques from Oberoi's code. Oberoi's code was a key to detecting dynamic subgraph patterns in temporal graphs, and we basically used that in the phase one of the project as well. And the original code creates dynamic graphs where nodes represent players and edges represent passes. And we adapted the code to handle our football dataset by adjusting for football-specific structures like home-away players. This way, we were able to divide the dataset into snapshots, which basically capture the passing patterns over short intervals. And this adaptation ensured compatibility with the pattern detecting algorithms. Next slide, please. And coming towards the data preparation and basically demonstrating the entire workflow. Uh, if I walk you through this, we understand that we started with the raw dataset in passes CSV file, which is basically the file that we were given. And using our code, we divided the data into snapshots, in which each represents a specific time interval. And finally, we're able to convert the snapshots into a dynamic graph where nodes are players and basically edges are passes, as I already mentioned. And these graphs allowed us to visualize and analyze the evolving passing patterns. Next slide. Coming towards the code implementation, our team was able to develop custom code to process the dataset efficiently, in which dynamic segregation of matches based on time intervals was done. Snapshot generation for both home and away teams was also done, and the formatting of the data was basically formatted into a graph-friendly structure for subgraph analysis. This implementation bridged the gap between raw data as well as graph-based pattern detection. Now Shazil will take over the next slides.
Okay, so good morning everyone. My name is Shazul Rahman, and now I would like to talk about identifying key passing patterns. Okay, so once the graph was ready, we identified the key passing patterns. For instance, triangular setups often indicate coordinated play strategies. We observed that Team 1 employed an aggressive forward passing style, while Team 2 focused on defensive retention. These patterns align with real-world football strategy and demonstrate how passing dynamics influence gameplay. Next slide. Okay, so additional insight related studies. A related study that inspired us was the football pass predicator FPP, followed by Frontier Vigor et al. This model predicts pass recipients by analyzing factors like player proximity and pass direction. It reinforces the potential of using machine learning and temporal graphs to understand team strategies. Next slide. Okay, so these were the code implementation and the main part of the code that we used to implement our strategies. Next slide. Uh, okay, to conclude and summarize everything, we processed a complex data set into dynamic graphs. Using adopted code, we identified and analyzed passing patterns. These insights revealed how football strategies evolve over time. Future work could involve richer datasets and advanced algorithms to uncover even deeper insights. Thank you for your time.
Thank you.